Okay, getting into the second half of Chapter 6, I should say the second of three parts, really. We're going to be getting into working with polynomials. And you can see our learning target. I can identify polynomials, state the degree, and state the lead coefficient. Now, a polynomial is going to be an algebraic expression, and it has real coefficients and exponents that are whole numbers. You won't have negative exponents. It'll be in standard form if those terms are written in descending order of exponents from the highest exponent to the smallest. The lead coefficient, we're going to talk about that a lot, is the number or the coefficient of that first term in standard form. It's the number in front of the highest exponent. And the degree, of course, is the highest exponent. A couple of things to point out to you, just to get you started, a few basic things. X will never be inside of a square root or a radical. X cannot be down below in a denominator, and X cannot have a negative exponent. You'll always have positive exponents. What you're going to see in Alex is you'll have your first question, very simply, a yes, no, is this function on the left going to be a polynomial? And what do you think? Answer is no. The problem is that x is in the denominator. You've got x to the fourth down below. How about this next problem? No. The problem is x is inside the radical. It's inside of a square root. That's no good. How about this next one right here? Yes. You've got really not every single power of x represented, but you could get there if you expand and if you multiply it through. And then likewise down here for this next one, that's going to be yes as well. You don't have a negative power. A negative can be in front of a number. You just don't want to see a negative exponent. If there would have been, say, a negative 2 up here, then we'd have to say no. All right, next problem. Remember, the degree was simply the biggest exponent, the biggest power that you ever see. What's the biggest power that you see? 6. And the leading coefficient is the number that's multiplied in front of it. Guess what that is? 25. Now, could we have rewritten that in standard form? We could. You know, and a lot of times that is easier for kids to see. I do want to let you know that that's fine. You know, then you could see why you could call it the leading coefficient. When you've got the highest power of x, then that would be the lead number. If I would have had a minus 25 there, I'd have to have a negative 25 for its leading coefficient. Okay, we doing okay? Let's real quickly go to the back. I can find all real zeros of a function. All the real zeros. Now, I do want to tell you that a zero means that your function, like f of x or g of x, you're going to set that equal to 0. And you can have more than one answer, and we can separate them by commas. Now, what I want to tell you is, ultimately, when you're multiplying through to get a 0, you can have these parentheses, these factored forms, equaling 0. That's the only way you can multiply to a 0. If the green highlighted expression could equal 0, or if this yellow highlighted expression could equal 0. And by the way, when you have something squared, here's another way you could look at it. This x minus 16 squared really is saying there are 2 x minus 16s. You could look at it that way. And that's definitely okay. Now, again, here, the only way this could equal 0 is if one of these two parentheses was equal to 0. You can add a 16, and you could see you'd get x equals 16. You'd do the same thing over here, guys. You'd get, x equals 16. Solving up in this way, you could minus a 5, and you'd get x equals minus 5. I think what can confuse kids sometimes is that as you're solving, you could get two answers that repeat. That's something that you need to be aware of in this Algebra 2 course, that you could get what's called a double root, an answer that would work twice. So look, when they're saying give the answer, you could say 16, 16, negative 5, or you could just write it down once. If you want to write it down twice, you may, and Alex will give you credit for it. But if you just want to write it down once, he'll give you credit for that also. Okay? Let's real quickly come over here for 4a. And I hope you can see the big difference is that now you've got three expressions with x. We've got this yellow expression right here. We've got this green right over here. And then we can say, well, we've also got this blue thing right here as well. So what's going on? Well, we can say very quickly, either the yellow expression could equal 0, the x minus 5 squared could equal 0, or the x plus 3 could equal 0. Any of those could equal 0 themselves. Now, if you've got x equals 0, guys, you gotta love it. You're done. You don't have to solve that at all. You've got your answer as is. Squaring something, you know, when you're squaring something, guys, that's like saying you've got x minus 5 times x minus 5 equals 0, and you'd set each of these equal to 0, and if you add a 5, you'd get x is equal to 5. You do the exact same thing here. So very often kids will say, well, it's going to be the same exact answer. Here you'd minus a 3, you'd get x equals negative 3. So really we're coming up with 4 distinct answers. It's just one of them is a double root. One of them would work twice. So you could write it down twice with the 5. But ultimately, if you just want to write it down once, you can do that too. Really, there are 4 answers. The 5 would count twice. Okay, we doing okay? Last one. This one might be the most complicated of all. And I do want to tell you that the directions are to find real solutions. So, tell you what, we can take this negative 4x, we can set that equal to 0. X squared plus 25, we could set that equal to 0. X squared minus 9, we could set that equal to 0. And x minus 7 squared, we could set that equal to 0. And we have to deal with all 4 of those. Well, if I were to divide by negative 4, I'd quickly see that x equals 0. Here, x squared plus 25, you could, deal with that, and we will in just a moment. The bottom line is this is going to be imaginary. If you tried to subtract 25, and if you took square roots, there'd be no real solution. You'd get imaginaries. And here we don't want to have imaginaries. We're just going to have real solutions. You get x squared minus 9. You could solve by taking square roots. But guys, very soon you're going to review the difference of squares factoring. And that's going to be if you had 2 terms, a squared minus b squared, that will factor into a plus b and a minus b. So hopefully you can see how this is very special factoring. Guess what this would become? X plus 3 and x minus 3. So I'm going to take x plus 3 and set it equal to 0. I'm going to take x minus 3 and set it equal to 0. And as we solve these guys, I hope you can see we'll get our two answers. We'll have x equals -3 and x equals +3. You could have taken square roots as well. You could have added a 9 and taken a plus or minus square root. But I want you to remember this factoring because it's going to come back very soon. Last one right here, you can see this is x minus 7 and x minus 7. That's what a square really is. And guys, as we work this out, we can take x minus 7 equals 0 and x minus 7 equals 0. Hopefully you can see as we work this out, you get the same answer. You'll get x equals 7. So as you can see here, we're going to have 1, 2, 3, 4, 5 real solutions. 2 of them have doubling. 2 of them, the 3 and the 7, count twice. But when you're writing your final answer down, you just have to write it down one time. Okay, and that's our lesson for today.